right, everybody, here is the last section for this chapter. We're doing 3.4 Part 3, and we're going to look at some special cases when we're solving equations. So our goal today is to determine whether an equation has one solution, no solutions, or is an identity. So this part where we have one solution, that's old news to us. Every equation we've been working with so far has just had one solution. So this business about no solutions or an identity, that's new, and that's really what we're going to be learning today, is how to recognize which one of these cases apply to our equation. So let's take a look. Now, the number of solutions. If an equation has one solution, that's an equation in which one number makes the equation true. And like I said, this has been every equation we've looked at so far. So for example, if I look at negative 2x equals 4, we know since this is negative 2 times x, to undo that multiplication, we need to divide. And we're going to divide by the exact number and sign. So I'm going to divide by negative 2, and I get x equals negative 2. That equation has just one solution, and the solution is negative 2. Now, sometimes something happens and we actually have no solutions. That means there are not any numbers that will make an equation true. So no matter what I plug in, that equation will never be true. And when that happens, when there are no numbers that make an equation true, we say there is no solution. So here's what that might look like. Let's say I have this equation 5x plus 3 equals 5x plus 7. So I look at that and I see an equation with variables on both sides. So I know my goal usually is to get all my variables over here to the left, which means I have to take these x's and move them over. So I'm going to do that by subtracting 5x. But now something interesting happens. When I subtract 5x, these x's go away and I'm left with 3. Over here, these x's also go away, and I'm left with 7. Now, we know that 3 is not equal to 7. When that happens and we get a false statement, we say that equation has no solution. Now, lastly, the identity is actually just the opposite of that. Sometimes any number we pick will make the equation true. So no matter what number we put in, that equation will always be true. So when all numbers will work, we say the equation is an identity. And so here's what that might look like. If I have an equation 3x plus 4 equals 4 plus 3x. Right? If I were to move all my variables over by subtracting 3x from both sides. Now, 3x minus 3x just gives us 0. And I have 4. Over here, the same thing happens, and I'm left with 4. Now, since 4 does equal 4, that's when we have an identity. So we're always looking for one of three cases. If I get x equals to a number, that means I just have one solution. If I end up with a false statement, that means I have no solution. And lastly, if I end up with a true statement, that's what we call an identity. So we're going to do 3 quick examples. And I don't have the directions here, so I'm going to put them here. Right? Our goal, our job, is to determine whether the equation has one solution, no solutions, or, make sure I'm not off the page, is an identity. So let's go ahead and try and solve these. So my first one, the first thing I notice is I have some parentheses that I need to deal with here on the right side. So I'm going to go ahead and distribute to take care of those. So I get 3x plus 3 times 3 is 9. Over here, I'm going to copy down my 29 minus 7x. So now I want to get all my variables to the left side, so I'm going to subtract 3x from both sides. My 29 comes down. I know negative 7 minus 3 is a negative 10x. Over here, my x's cancel, and I can bring down my 9. Now I'm down to a two-step equation. I'm going to move this constant over, my minus 29. That goes away. My negative 10x comes down. 9 minus 29 gives me a negative 20. My last step then is to divide both sides by negative 10. And x is equal to 2. Since I got x equal to a number, I know I have one solution. So let's see what our other problems get us. My next problem, again, I can see that I have some parentheses to deal with here, so I'm going to distribute. And I get 8p plus 40. And we think that's equal here to 8p plus 38. So now I'm going to move my variable to the left side, just like always. So I'm going to subtract 8p. P's drop out, and I have 38 left. Now over here, when my p's drop out, I have 40. But there we go. We have that false statement. 38 is not equal to 40. We know when it's a false statement, we have no solution. All right, so the last piece then over here. I don't see any parentheses, but what I do notice is that I have some like terms on this side. So I'm going to go ahead and combine those before I try to solve. So negative 7 plus 6v. And over here I have negative 7 plus 6v. Well, right away I notice I have the same thing on either side of the equation. So that's kind of letting me know I'm going to have an identity. If I were to move my variables over, these 6v's are going to go away. I have negative 7 on this side. Again, these are going to cancel, and I get negative 7 is equal to negative 7, and that's an identity. So this is, like I said, the last section on this chapter. So you guys are going to have time to practice with this, and then we're going to move into some chapter assessments before we head on to finals.